Hi guys, Ryan here with our lead engineer, Doug Keller. Today we're going to be talking about our titanium gear. We're going to give you an update today on our STC, PMA approval, and then some of the aesthetic finish that we have for the titanium gear. I'm going to hand it over to Doug Keller, our lead engineer, to kind of give us a background on how we started to make this product.
Yes, it's always been a dream of mine to have titanium gear. Again, the theme of lightweight products. This is designed in the 40s, 50s, and back then they didn't have advanced materials. So we're trying to take advantage of new materials, make things lighter. Again, a lighter airplane is a better performing airplane. Yeah. So titanium was kind of a logical place for us to start. Again, our hope is that now that we've developed the welding and all the processes, that we can move on to other products. But the welding is probably the biggest hurdle that we had to overcome. Welding titanium is difficult, and we tried to do it in open air. We didn't do very well, so we end up welding it in a chamber, inert chamber. So it's very complicated, very time consuming, very expensive.
So what happens when you weld titanium in open air?
So the air contaminates the weld. So it's pretty easy to spot that. It's a bluing of the titanium near the weld.
Got it.
And we use large cups to do it in the open air. Titanium bicycles are mostly welded in open air. Yeah. But obviously an aircraft part is more critical than a bicycle. So just to eliminate all probable causes or anything, we decided to go in an inert chamber. Right. Now that was expensive to buy, expensive to purge, cumbersome to weld in, but it guarantees that we have a very good final product.
Got it. So in that chamber, we're using argon to help prevent contamination. Is that true?
Correct, yes. We have to purge all the air out of it. Everything has to be cleaned. It's just totally different than welding steel.
Right.
It's just the cleaning and prep alone is way more than welding a whole steel gear.
Right. So the reason that we use the chamber, as Doug said, is we're trying to make sure that we have the most pure welds possible when we're building this titanium gear, because safety is paramount. It's not just about aesthetic, it's about reducing weight, but it's also about safety. So that's part of the reason why we use the argon chamber. So we recently got STC approval for this gear, and we also got PMA approval. Could we talk about that?
Well, yeah, that goes back to the chamber. We have to prove to the FAA that we're going to have very repeatable, high quality welds. Everything has to be repeatable. So we got an STC for this gear. It's 3-inch extended, and it's got at this point we only have 1.5-inch axle diameter. We're investigating different 1.25-inch in the future. Again, this is our very first welded titanium fabricated part. And again, hopefully we'll be able to expand that over time to other parts, hopefully seat bases, torque tubes, flap handles, all sorts of stuff.
Yeah. So then I want to talk about the testing. We put this through rigorous testing, through tons of off-airport, really rigorous, like hardcore backcountry flying. It wasn't just done on strips, like local strips. We took this into real backcountry flying. Could you tell us about that process?
Yeah, so the reason we did that is because titanium has different mechanical properties than steel. So titanium is very strong, very light, but it's very elastic. So as you'll notice, the tube diameters this is 1.75 inches, where our heavy duty steel is 1.5 inches. We had to upsize the tubes more so than our heavy duty steel gear, and we flew this gear, multiple iterations of this gear, both welded outside the chamber, inside the chamber, on experimental cubs for a good year. Up here in Alaska, we had a prominent bush pilot really beat on it.
Right.
And then that was flight testing, and then that's unofficial FAA testing. That's for our own company testing. And then we had to do a structural test where we had to compare this gear to our heavy duty gear, make it as stronger. So we deformed them, bent them. This is our static test, not drop test. And then we made them as stronger than our heavy duty steel.
Yeah, got it. Okay. And so we have our first 5 sets that we manufactured. Those are now out to customers. They're in the field. We're working on our next run of titanium gear. Could you tell us about some of the things we might see with the titanium gear, including some step options?
Yes. So here is a right-hand step. It's our long step. And to be in par with our lightweight gear, we cut some more holes out to get the weight out of the aluminum step. On the left side, we're working right now on a bolt-on fueling step for those guys that go on skis so they can fuel the airplane. We don't have that to sell right now, but it's in the works.
And what are those steps made out of?
This is aluminum, and the bolt-on will be aluminum as well.
Okay, got it.
So, again, there's no reason to put a big heavy steel step on if we're going to go to the effort of titanium gear. So
yeah,
we got to keep it with a low weight.
Right.
Objective.
And then how about another component that pairs with the gear is the cabane V?
Yes. So this airplane has it on there. It's titanium as well. So it kind of gives you the whole landing gear system. And hopefully soon we'll have a new suspension system to complement that as well.
Right. Yeah. As Doug mentioned, we're working on a suspension system. What can you expect from that product, and then possibly when?
We got all our design done. We're building our final test articles, and we have to do drop test and flight test. Now the flight test is just official FAA test, which is pretty benign compared to what we've been doing in the field.
What makes it stand out from others?
Well, it's like an off-road type vehicle suspension that has lots of dampening. So it doesn't really have, it has more travel, but not that much. But basically, as you land and splay out the gear, it's not going to come back real quick. It's going to take a while to come back and not rebound. So basically the idea is to keep the wheels on the ground through rough terrain.
Got it.
And not bounce.
Okay.
You could drop it in more aggressively.
Got it.
Now our tires give us a lot of absorption, but with this suspension, we shouldn't rebound.
Okay, if you guys have any other questions on titanium gear, please send us a message at info@airframesalaska.com. You can also visit us and see the titanium gear in store if you're local here. Otherwise, go to airframesalaska.com for full specs, details, and pricing. Thanks.